Hello and welcome to ResearchPod. Thank you for listening and joining us today. In this episode, we look at the work of José Antonio Chamizo, initially a researcher in organometallic chemistry, who is currently dedicated to the philosophy of chemistry. As the French sociologist and philosopher Bruno Latour remarks, the word substance does not designate that which underlies, impenetrable by history, but what brings together a multiplicity of agents and makes them a coherent and stable whole. A substance is more like the thread that links the pearls of a necklace than the living rock that remains unchanged, no matter what is built on top. Substance is a name that designates the stability of a set. Chemistry, as we know it today, is a system of scientific experimental practices, stabilized and taught in the same way in most countries. It is the inheritor of several trades whose objective is to transform and create new substances. I discuss here the material limits of the chemical substance, exemplified by carbon, and particularly by the C60 diffraction experiment published in Dia Neue, a philosophy journal from the National Autonomous University of Mexico. I thus intend to clarify the concept of chemical substance and its relevance in the current philosophical discussion. In 1732, in Europe, chemistry emerged as an independent science with strong and stabilized shared practices, didactics, industrial, and experimental. Since 1818, it has undergone four major transformations, characterized by the appropriation and accumulation of new epistemic objects or hidden entities, the first of them chemical atoms, that continue to be used today, and by the emergence of new subdisciplines such as organic chemistry, physical chemistry, instrumental chemistry, and organometallic chemistry, among others. Chemistry is thus a pluralistic, relatively young discipline that has integrated a multitude of millenary trades, today transformed into technosciences, a place where it is studied, practiced, and transmitted how to manufacture and transform substances in small and very large quantities. Chemistry is mainly about chemical reactions. In the scientific practices of chemistry, the laboratory is the central place where the chemical experiment is carried out. Chemical practices, such as analysis and synthesis, are different from other scientific practices, particularly those from physics. By participating in a practice, one knows what to do and what to say, although part of the knowledge about it is tacit knowledge. Chemical practices are related to Thomas Kuhn's exemplars, that is, a collection of problems, theoretical and experimental, shared and solved by a specific community at a particular historical moment, that are generally found in professional publications, and especially in their own discipline textbooks. It is apprenticeship in the regimented discipline of the chemical community that allows transmission of purposes. Chemical practices do not try to discover what matter is like. What they mainly seek is to build new substances. Substances are the ontology of chemical practices. Through his synthetic practices, the number of substances grew from several hundred in 1800 to more than 150 million at the beginning of the 21st century, most of which are commercialized. And every day, and day after day, more than 15,000 new substances are added to the world, posing a major ethical problem. Substance is a fundamental concept in chemistry. Suffice it to say that chemical change is identified as change of substance, and that mole, one of the 7 basic units of the International System of Units, is used to measure the amount of substance. But what is a chemical substance? This is not a simple question, and, as it is in the case of these situations, there are several answers, depending on who is asked. First, I will consider a briefly historical approach, and then the answers of 2 present-day different communities, philosophers of chemistry and professional practitioners of chemistry. During the first chemical transformation, Dmitry Mendeleev distinguished between the elements as simple substances and as basic substances. A simple substance is something material, metal or metalloid, liquid or gas, endowed with physical properties and capable of chemical reactions. The word element corresponds to the idea of an atom. Hence, carbon, a basic substance, is an element, but coal, graphite and diamond are simple substances. Mendeleev used basic substance with an important theoretical role. Because chemistry is concerned with the explanation of chemical change, basic substances survive chemical change, which means that persists and can explain the properties of compounds. Since then, and until Henry Moseley proposed the concept of atomic number to replace the atomic weight during the second chemical transformation, the atomic number became the essence of a particular basic substance. With the massive advent of spectroscopic instruments during the third chemical transformation at the end of the Second World War, the relational macroscopic chemical characterization of substances from specific reactions with other known substances gave way to microscopic absolute physical characterization. The German philosopher of chemistry, Joachim Schumer, clearly states it. The most important impact of spectroscopic methods was that it finally made chemists decide in favor of molecular species. Once established as independent means of structure determination, spectroscopic methods were also used to characterize quasi-molecular species for which there exists neither a corresponding chemical substance nor a classical approach of chemical structure elucidation, such as conformational states, intermediary states in solution, van der Waals complexes, molecular fragments in mass spectrometry. Furthermore, the approximation of the professional communities of chemists appeals to specify technically what they understand by chemical substance. The two largest and most important associations of professional chemists worldwide do not coincide, since for the International Union of Pure and Applied Chemistry, chemical substance is matter of constant composition best characterized by the entities, molecules, formula units, atoms it is composed of. Physical properties such as density, refractive index, electric conductivity, melting point, etc. characterize the chemical substance. Following suggestions of well-recognized public organizations, either from industry or from academia, the American Chemical Society indicated that chemical substances, recognized through its Chemical Abstract Service Registry number, are elements, organic compounds, inorganic compounds, metals, alloys, minerals, coordination compounds, organometallics, isotopes, nuclear particles, proteins and nucleic acids, polymers, non-structural materials, known, variable, composition, biological. That is to say, not all Chemical Abstract Service Registry number substances are substances according to the IUPAC. Finally, in a detailed and extensive study of substances, both from a philosophical and chemical point of view, the Belgian philosopher of chemistry, Jaap van Brakel, identifies them as the ontology of chemistry and specifies its meaning as follows. Perhaps we must limit the notion of substance to what can exist independently in bottles. During the fourth chemical transformation, the first spherical molecule, the most beautiful molecule, the C60 buckyfullerene, was unexpectedly discovered. The American and British chemists Harold Kroto, Robert Curl, and Richard Smalley were awarded in 1996 with Nobel Prize in Chemistry for their roles in the discovery and related class of molecules first generated a decade before. Few years after its discovery, the way to produce C60 was found to have practical utility in chemistry laboratories. In other words, C60 was produced, characterized, purified, and sold in bottles like any other substance. Since then, the price of C60 was fallen from $2,000 for a gram in 1992 to $500 in 1993 to $165 these days, which led to an impressive development of synthetic chemistry and also to nanochemistry. Nevertheless, in 1999, that molecule, in an experiment that resembles very much the standard Young's double-slit experiment, C60, was diffracted. That year, at the end of the fourth chemical transformation, a team of Austrian physicists led by Anton Zeilinger, who in 2022 won the Nobel Prize in Physics, took from a bottle of Dynamic Enterprises Limited, a British chemical commercial company, the solid and black substance C60, 99.5% pure as determined by HPCl. No doubt, C60 is a substance in a bottle. Subsequently, they sublimated it, collimated the emerging molecular beam and diffracted it through a double slit. In that experiment, a multitude of those molecules coming from that substance were the most massive and complex material object in which wave behavior has been observed. Thus, from an unequivocal and material chemical substance with well-characterized physical and chemical properties, a multitude of chemical species are extracted, mainly the C60 molecule, which, in a certain context, behaves like a wave. Since then, many similar experiments were performed with larger molecules, not necessarily spherical as phthalocyanines, M equals 151 atomic mass unit, composed of up to 430 atoms, following library approach towards stable and volatile high-mass molecules. With 810 atoms, M equals 10,123 atomic mass unit. The molecules were detected using electron impact ionization and/or quadrupole mass spectrometry. These experiments show that under appropriate quantum circumstances, huge molecules corresponding with particular chemical substances can be delocalized over hundreds of nanometers, a distance exceeding their size by orders of magnitude. In a specific context, chemical substances behave like waves. It is very important to understand that, for chemists, what is important is how to synthesize substances with certain properties, consolidate their professional practices, and not whether these substances, at a certain moment in a specific experimental context far from said practices, cease to be such. From their stubborn, stabilized, and successful material practices, the immateriality of the individual molecule seems to be a limit, but it is not. Chemical substances, in their macroscopic, observable condition, with an independent existence in bottles, have relational properties that are subject to a context, that of his possible reaction. Chemical changes, that is, how some substances transform into others, are the subject of chemists. The physical properties of substances, such as their ability to diffract under certain conditions, is a topic for physicists. Chemistry cannot be reduced to physics. That's all for this episode. Thanks for listening. Links to the original research can be found in the show notes for this episode, or visit joseantoniocamizo.com. And as always, stay subscribed to ResearchPod for more of the latest science. See you again soon.